here we are again. Tried to do this earlier on, but too escorcho, too bright. You know, the absolute light the sun does. What are we doing? What we have is 1 centimetre cut out, right, that runs for 25 centimetres. Now, the sun, right, is a give or take a gnat's whisker, right, from here, has a diameter of about 1 centimetre, right? So what we have is 1 centimetre bottom to top, right? And the sun is bang, just perfectly in there, like centimetre. It's lovely, snug fit. And we've got 25 centimetres running from left to right, or from right to left, funnily enough. Right, see how it's dropping, so I have to come back a little bit. Look at those rays, look. All the way from the sun to here. Because it is, isn't it, really? It's like 150 million kilometres and I hit, boom! Isn't it? So, we know that the speed of light, 299,792, right? At that speed, light takes 4.6 seconds to travel the distance of the diameter of the sun, which is 1,390,000 kilometers. All right, 4.6 seconds per diameter. Now, believe it or not, this is extremely close, right? So if we go that way, we've got 25 centimeters. So let's say we start from there, right? We're going to start from there. Right, so we now have, that sounds beautiful, isn't it? Look at it. We've got 25 centimetres. For the sun to travel that distance, do you know how long it's going to take? It's going to take 1 minute and 55 seconds. Not for the sun to travel, for the sun's light. Now this, ladies und Herren, yeah, that's right. This is to scale. Everything is to scale. It's like it's supposed to be. No, it's Mickey Mouse science. Everything is to scale. See that sun? About 1 centimetre in diameter. So if we were to sit here or stand here, right, and the sun was off and it suddenly turned on, it would take 1 minute and 55 seconds. We would see the sun's light travel at 299,792 kilometers per second. Because it's a sun diameter, and a sun diameter, and a sun diameter, and a sun diameter. They're sun diameters. 1 centimetre will get 25 suns in there. All right. So it would go something like this. And so, all right, look, the sun's off, and oh, Marco Polo, turn the sun on. Okay, I turn it on now. Galileo. Okay, so you turn the sun on, it's light. It starts to go like this. 4.6. 4.6. Oop. 4.6. All right, look, it's good. 4.6. This is what we're talking. 4.6. This is your speed of light. 4.6. 4.6. 4.6. This is how you would see it at this distance. Well, you wouldn't actually, because you can't see it from planet Earth, can you? If it's off for 8 minutes and 20 seconds. It is so stupid, right? Sorry, 4.6. 4.6. So we are following the sun, but it would be the sun's light, all right? So that we could be, what, close to a minute now, all this, right? It's got another 55 seconds to go. That is the speed of light. That is a 1 centimeter diameter sun. It would take the sun 4.6 seconds. It doesn't matter how big the diameter is. It takes 4.6 seconds per diameter. So get that right, okay? So what, minute and 15? Keep going. Oh, did a little hop, skip and a jump there. A bit of absolute light going on there, right? And then 1 minute 55, and now this is a fact, right? An approximate diameter of 1 centimeter. The sun takes 4.6 seconds to radiate its light the distance of its own diameter. All right? Below the cutout is 25 centimeters. I measured it. That cutout is 25 centimeters. 25 centimeters multiplied by 4.6 is 115 seconds. That's 1 minute and 55 seconds. For the sun's light, oh god, this tripod keeps getting stuck. To travel that distance, that is a fact, right? Using the sun's diameter again. 4.6 seconds for each one. So what we would have seen, right? What we did just there, where's my pointer gone? We are us, the blue dot, the blue planet, and we're looking, we'd be just on kind of over there, on that side, right? Because the sun's going down. And it's 150 million kilometers over to the left, yeah? Over to the left. So what we just did, we watched it travel 25 sun diameters, right? It's bigger there. Let's not start that nonsense, okay? So we saw it travel 25 sun diameters. There are 108 sun diameters in between Earth and the sun, 150 million kilometers. So what we just did up there, what you just saw, right? If we divide 108 by 25, that's 4.3. We just saw the distance, right? Just over a quarter of the distance from the sun to Earth. That travel, what you just saw up there. So if we did that another 4 point something times, right, where that sun is, if we did that another 4 point something times, right, from there, 4.6 times, and it went 1, and then another 1, another 1, another 1, and a little bit, that would be 150 million kilometers, because it's to scale. It's at a slight angle, yes, but the sun's diameter is the sun's diameter, isn't it? And there are 108 of those sun diameters in between us and it. So as we look at it going from left to right, it stays the same distance, doesn't it? So that is a fact, Jack. That's it. It's going to go down now. I'll just tilt this a little bit. So it's going to be trouble in a minute when it goes over. Okay. That's sunlight. I mean, what is that? What are those rays? What is that? I mean, something that's coming all the way from the sun in an instant, isn't it? Shooting out the other side. 4.6 seconds. 299,792 kilometers per second. You know what? It's a lack of common sense that's driving this planet into the ground. They've got people believing in absurdities. light from the sun is absoluto. Oh, 10 minutes. Perfect. Later, peeps.